Right? Is the PowerPoint visible to you?
Yes, sir.
Okay, fine. So in the last class we were discussed about the refrigeration. So the performance of the refrigeration is compared with the COP. So we can have these refrigerators and the heat pump differentiation. Then the typical refrigeration cycles flow diagram is given there. So just so we have two types. One is vapor compression refrigeration system. Then another is vapor absorption refrigeration system. Also there are other different types, but we need to focus on the VCR and VCR. So in the last class we discussed more about the VCRs. So the refrigerant used in the VCR is R11. Also CSEs may be used. Then this is the components in the VCR. So we have a compressor, evaporator, then condenser, then expansion valve. Then the flow diagram, then the parts, then TS and pH diagram. So this TS diagram is important for you. So in this we have two isentropic process, then two isobaric processes. Then we discussed about the components. Then the expansion device used here is thermostatic expansion valve. Then the other VCR cycles, so the thermodynamics of VCR cycles. Then the formulas involved in the VCR. Then the importance of VCR COP. So COP output by input. So the desired output is Q in, that is cooling temperature, cold temperature. Then input is the TH minus TC. Then we solve this problem with the use of our property tables and chart for refrigerants. Then the features of actual vapor compression cycles also stated. Then then we solved one problem with these values. Then the other refrigeration cycles with VCRs were discussed. So is it possible the cascade refrigeration system with the addition of two refrigeration systems in series? Then there is a multi-stage compression refrigeration system also possible. So we have to provide two expansion valves. So the flash chamber will separate the mixture, that is a subcooled liquid. Then it will again pump to the evaporator to get the cyclic process. So we can get the improved COPs. So also there is a multi-purpose refrigeration system with this throttling refrigerant in different stages also available. So we can get these different stages with the use of this multi-purpose refrigeration system. And so here in multi-purpose we can use the exist for kitchen air. So also liquefations of gases possible with the use of this VCR. The thing is we need to provide additional regenerator. So if you see in this flow diagram, just the outlet from the heat exchanger is passed through the expansion valve. Regenerator. So you know how the regenerator will work. So regenerator can take the exit of a heat to again reheat the regenerate the properties of the medium. So this is the line. So from 4 to 5 and 8 to 9 we attached a regenerator. So this so the heat transferred in this 4 to 5 process is used to add heat in the process 8 to 9. Then after the expansion, you will get the subcooled liquid. That subcooled liquid is removed with the use of this separate provisional. Then this vapor alone used for the circulation again. Right. So another way to improving the performance of vapor compression refrigeration system is by using multi-stage compression. So here we can use the multi-stage compression. With the regenerative cooling, the vapor compression refrigeration cycle can also be used to liquefy gases after some modifications. So we can get these kind of TS diagram with the use of this liquefaction of gases. So this is also possible with the use of regenerator. So then the next type of refrigeration is vapor absorption refrigeration system. So just these are the components involved in the vapor absorption refrigeration system. So instead of our evaporator, so here instead of compressor, here we have uh, heating generator. Its source is provided. So where in the case of vapor compression VCR system, we will give work as an input. So here we will give the heat as an input. Just you can see this. Right, so just here you can see we can give the heat source as an input in the vapor absorption refrigeration system. So vapor absorption refrigeration system, it differs from the vapor compression systems only in the method of compressing the refrigerant. So we use compressor, where in the case of VCR to get the compressed refrigerant. Here in the case we will use a different method. The compressor is replaced by combination of absorber, generator, and a pump. So we need to replace a compressor with these three components. So namely absorber, generator, and a pump need to replace compression in this VAR refrigeration system. Then here the working medium will be mostly ammonia. Ammonia will be worked as a refrigerant here. So this will give you the line diagram of our VCR, the VAR. So the other processes will be same. So we have evaporator, we have condenser, then we have expansion device. Then the compressor is only replaced with these three components. So we need absorber, we need vapor generator, and we need a pump. Right. So the working refrigerant in this vapor absorption refrigeration system is ammonia. So ammonia can be in different forms like vapor, then subcooled liquid. So just we can take this. So in the absorption refrigeration system, refrigeration effect is produced mainly by the use of energy as heat that we discussed. In such a system, the refrigerant is usually dissolved in a liquid. So ammonia here is dissolved in liquid. A concentrated solution of ammonia is boiled in a vapor generator producing ammonia vapor at a high pressure. So just if you take if you see in the vapor generator, the ammonia mixed in the water is taken as a medium, and if that is heated with the heat source, just we can able to produce the high pressure ammonia vapor, right? So that can be used for the refrigeration purpose. So the high pressure ammonia vapor is fed to a condenser where it is condensed to a liquid ammonia by rejecting energy as a heat, so heat to the surrounding. So if you this process, so this is the second component is condenser. So this high pressure ammonia, if passed through this condenser, yes, we can get the liquid ammonia again. With the ejecting energy as a heat with the surroundings. Then the liquid ammonia, so this energy can be used for our cooling purpose. Right. So then the liquid ammonia is throttled through a valve to a low pressure. So after this condensation, we can get the liquid ammonia with high pressure. So we have to reduce the pressure with the use of this throttle valve. So the inlet of the throttle valve will be liquid ammonia with high pressure. Then the exit will be liquid ammonia with the low pressure. Right. So that liquid ammonia with low pressure will pass through this evaporator. Then in this during this throttling, ammonia is partially vaporized and its temperature gets decreases, that we know. Then the low temperature ammonia is fed to an evaporator, the next component, where it is vaporized, removing energy from evaporator. So after throttling process, the liquid ammonia gets vaporized in evaporator. Then this low pressure ammonia vapor is absorbed in the weak solution of ammonia. The resulting strong ammonia solution is pumped back to the vapor generator. So after the evaporator, we will have the absorber. So already we have the weak ammonia in this. So this liquid low pressure ammonia also, liquid low pressure vapor also mixed with this ammonia immersed in the liquid or water. So we can get the weak solution of ammonia. Then again this will pumped to the vapor generator. Then we can get the cyclic process. Right. So concentrated solution of ammonia is boiled in a vapor generator producing ammonia vapor at high pressure. Then the high pressure ammonia vapor is fed to a condenser, where it is the condensed of liquid ammonia by rejecting energy. So we discussed this one, right? Right. So here, so the resulting strong ammonia solution is pumped back to the vapor generator and the cycle is completed. The COP of the absorption system can be evaluated by considering it as a combination of heat pump and a heat engine, right? So in vapor absorption refrigeration, we can get the combination of a heat pump and a heat engine. So to calculate the COP of the refrigeration system. Then, so the advantages of vapor absorption systems were no moving parts involved here. Then the low grade thermal energy like solar energy can be used as an input energy. Then load variation does not affect system performance. Then the environmental friendly system is VAR system. So the selecting refrigerants is another important thing in the refrigeration system. So the refrigerant selection is based on these several factors. So performance, based on the performance, the refrigerant should provide adequate cooling capacity and cost effectively. Then based on the safety, so the refrigerant should avoid hazards like toxicity. Then it should have environmental impact. So it should minimize harm to stratospheric ozone layer and reduce the negative impact on global climate change. Just you may aware that our refrigeration and air conditioning system will affect our ozone layer. So we have to be careful while selecting the refrigerant. So the refrigerant should be environmental impact. Should have environmental impact. Right. So these are the different types of refrigerants, and its characteristics were stated here. So we have CFCs, HFCs, and natural refrigerants also there. So the CFCs mainly R12, R11, R14, R134. So the chemical formulas also stated here. Then the GWP values were given here. So GW means the global warming potential. So this is for the ocean depletion. So we can have the lot of refrigerants, and the GWP numbers. So we have to choose based on our requirements. Right. So we have CFCs, HFCs, then natural. So we can look what is CFCs, HFCs, and natural refrigerant in the next slides. So before we can know what is GWP. So GWP stands global warming potential. Is a simplified index that estimates the potential future influences on global warming associated with different gases when released to the atmosphere. So these gases may be uh, given to the atmosphere as an exist of the refrigeration and or air conditioning system. So that may affect our GWP. Then, so we have different types of, as I said earlier, we have different types of refrigerants. So the first type is CFCs. CFCs means chlorofluorocarbons and hydrochlorofluorocarbons also available. So these are the early synthetic refrigerants, each containing chlorine. Right. So in this refrigerant we have chlorine. Because of the adverse effect of chlorine on Earth and stratospheric ozone layer, the use of these refrigerants is regulated by international agreements. So actually these refrigerants are obsolete here now. Then we have HFCs also there. HFCs is hydrofluorocarbons. So here we can we don't have the chlorine, but we have hydro. Right, so the chlorine-free refrigerant is HFCs. Then blends also possible. So blends combine 2 or more HFCs. While these chlorine-free refrigerants do not contribute to ozone depletion, with exception of R1234YF, they have high GWP level. So we can use these HFCs, but except this R1234A, the other HFCs having high GWP level, so we have to consider this one. So just you can compare here. Right, so this R1234YF alone having low GWP, except others. Then we have another refrigerant, natural refrigerants. These are non-synthetic, then also naturally occurring substances which serves as refrigerants. So these includes carbon dioxide, ammonia, and hydrocarbons that we know. Now normally we will use these natural refrigerants. So these refrigerants features low GWP values. So still concerns have been raised over toxicity of ammonia and safety of the hydrocarbons. So we can use these natural refrigerants, but there is some disadvantages like toxicity of ammonia and the safety of our hydrocarbons. So these are some advantages and disadvantages of the refrigerants and the type of refrigerants. Then we can define refrigerant. So any substances capable of absorbing heat from another required substances can be used as a refrigerant. Right. So also possible like ice, water, and brine or air, etc. can be used as a secondary refrigerants. Right. So from this criterion we can classify the refrigerant as a primary refrigerant and a secondary refrigerant. So primary refrigerants, they take a part directly in refrigerating system, like examples are freon, ammonia, carbon dioxide, sulfur dioxide, etc. So we can use the freon, ammonia, carbon dioxide, sulfur dioxides directly to get the refrigeration effect. But in the case of secondary refrigerants, first they are cooled by the primary refrigerants and they can circulate it. Like the examples of secondary refrigerants are chilled water, then brine solutions. So already I said what is the brine. So brine is used for getting ice bars. So just actually it's a cold medium. So this may be used as a secondary refrigerant. Then this secondary refrigerant is cooled by the use of primary refrigerants. Right. So then the importance of refrigerants is the refrigerant is the working fluid used the refrigerators that you know. The commonly used refrigerants are ammonia. Then used in ice plants. This ammonia may be used in ice plants, large cold storage, then scattering rings. So then we have a second carbon dioxide as a refrigerant. So used in marine refrigerators, dry ice making, etc. Then we have methyl chloride. So this methyl chloride is used in domestic and industrial refrigerators. So now obsolete. So obsolete means that there is no existence. So methyl chloride is obsolete now because of some disadvantages. Then we have fluorocarbons like freon, freon 11, 12, 13, 22. That means R11, R12, R13, R22, R13, etc. Right. So we have fluorocarbons. Then we have carbon dioxide. We have ammonia. Then we have methyl chloride as refrigerants. Then these are used in domestic and industrial application. So these chemical damage the ozone layer and hence they are being replaced. So we can use this refrigerant, but this were involving the damages in the ozone layer. So just we are trying to replace these refrigerants. Then the properties of an ideal refrigerants to be studied. So the an ideal refrigerant should be satisfy the following thermodynamic, chemical, and physical requirements. So each and every refrigerant should satisfy these requirements. So in thermodynamic properties, that the refrigerant should have low boiling point. Then it should have high critical temperature and low critical pressure. Then the refrigerant should have a freezing point should be lower than the refrigeration system temperature to avoid blocking of pipes. So the freezing point should be carefully taken. Right. So if the freezing point is greater than the refrigeration system temperature, so there is a possibility to get a freeze, then that will cause the blocking of pipes. Right. So we have to choose the refrigerant accordingly. Right. So based on the thermodynamic properties, the refrigerant should be low boiling point, should have high critical temperature and low critical pressure. Then freezing point should be matched. Then the thermophysical properties of refrigerants should low viscosity, then high thermal conductivity, then high latent heat of vaporization, then low specific volume, then low specific heat to be there for the refrigerants. Right, so we need a low viscosity refrigerant, we need a high thermal conductivity refrigerant, we need a high latent heat of vaporization refrigerant, then low specific volume, then yes, low specific heat. So the refrigerant should satisfy these thermophysical properties. Then in the point of chemical requirements, so the refrigerant should be non-inflammable, then it should be not toxic, then should be non-corrosive to metal, then should be capable of mixing well with the lubricating oil, then the electric resistance should be high, then the leakage should be detected easily, then the refrigerant should be odorless. Right, so these are some requirements of our refrigerants. So we can classify based on the thermodynamic property, then thermophysical property, and chemical property. So the domestic refrigerator, what we are using in our home is compared here. So normally VCR, vapor compression cycle is normally preferred over absorption system in domestic refrigerator because its compactness and more efficient use in electrical energy. Right. So normally our home refrigerators worked with this VCR system. Then the refrigerant used in this domestic refrigerator is R12, maybe R22. Then this is our line diagram of our domestic refrigerator. Just you can refer this. So we have compressor. The important part of the domestic refrigerator is compressor. So we can get the high pressure gas with the use of this compressor. Then this high pressure, high temperature gas is passed through this condenser. Then with the use of these radiator fins, we can transfer heat to the atmosphere. Then So if the heat is transferred, then we can get the liquid. Then this liquid is passed through the expansion valve. So after the expansion valve, we can get the subcooled liquid again. Then this will pass through the subcooled liquid, right? So we can get the chillness, cooled. So these cooled liquids were passed through the evaporator. Then this cooling can be transferred, or the heat is latent heat of the inside the fridge is transferred to the medium. Then we can get the again low pressure gas after the exit of evaporator. Then again this low pressure gas is passed through the compressor. Then we know the function of compressor. Then low pressure gas is compressed with the high pressure gas. Then there is a cyclic process again. Just you can refer this. So actually this domestic refrigerator is a working application of our VCR system. Then the another application of our refrigerator is ice plants. So actually this is a circuit diagram of our ice plant. So here we have a primary ammonia circuit. Then here we have a secondary brine circuit. So we know, so this absorption, right? So the primary ammonia circuit is with the use of VCR, right? So there is a compressor, there is a condenser, there is a receiver, then there is an expansion valve, again there is evaporator. Then this evaporator is attached with the secondary brine circuit. So just we can circulate the brine. So actually brine is a cold medium. We can use the water as well brine to transfer the heat. Right. So in the primary circuit, primary ammonia circuit, yes, we can have the explanation here. So there is possibility to transfer the heat with the use of water, also with the use of this brine. So if the heat, the cooling is transferred to the brine, there is a possibility to make ice. The ice will be formed in this ice can. Right. So the simple VCR cycle is used in primary circuit using ammonia as a refrigerant, and the brine is a secondary circuit. So that we know. So this is a direct method of cooling used for ice production. So the ice can contain water which reject heat to the brine, which is circulated in secondary circuit. Right. So the rejected heat of the brine can form the ice with the use of water. Right. So in evaporator, the heat of a brine is transferred to the refrigerant in primary circuit, and brine is cooled. Right. So again, so we know. So actually, after the expansion, we have a subcooled liquid. Right. So this cooling heat transfer this evaporator to the secondary brine circuit. Then this cooling can be used to get the formation of ice. Right. So in evaporator, the heating of a brine is transferred to the refrigerant in primary circuit, and brine gets cooled, that we discussed. Then the vapor refrigerant from form in evaporator is sucked by the compressor. Then it's compressed to high pressure. Then this condensed in condenser with the help of cooling water. This is the primary circuit. So after this exit of evaporator, we can get the low pressure vapor, right? So this low pressure vapor is again sucked by the compressor, then compressed to get the high pressure vapor. Then again this will pass through the condenser. So there is a chillness. So the chillness can be transferred with the use of this pumping arrangement. So actually this water tank, so with the use of this, so natural cooling will happen here, natural cooling tower. So normal air will pass through this. Then we can get the water pump. There is a circulation of water, right? There is a circulation of water. Then we can get the natural cooling of air, right? Then the high pressure liquid ammonia is collected in the receiver, and then it is passed through expansion valve, like our previous, what we discussed in our previous case. There is a the throttle liquid ammonia at a low pressure and temperature enters our evaporator. So brine is cooled and ammonia absorbs heat from vapor, right? So just the latent heat is the coolingness of the primary medium is transferred to the secondary circuit. Then with the use of this cooling, we can get the ice, right? So in your syllabus, we need to compare the COP of refrigeration. So here the COP increases with the rising evaporator temperature. So we know the formula. COP of a refrigerator, COP is output by input. So here TL, T low divided by change in temperature. So if we increase the evaporator temperature, there is a possibility to increase the COP of the refrigeration system. Right, so we know where the evaporator involved. So if we increases the temperature of this evaporator, there is a possibility to increase the performance of the refrigeration system. Also, so the COP increases with the decreasing condensing temperature. So we know where the condenser is attached. So if we decrease the condenser temperature, there is a possibility to increase the COP of the refrigeration system. So with this, so the first unit of our the first half of our unit 4 is completed. So just we can move to the next half of your fourth unit. So air conditioning. Right, it's like refrigeration, air conditioning also. A system, the thermodynamic system to get the controlled air. So here the working medium of the system is air, that you know. So we need to discuss the basic principles, then the types of air conditioning. That is enough. So where in the case of refrigerator, we will use refrigerant as a medium, but in air conditioning, we will use air as a medium, right? So we know we have to, in air conditioning, the name itself, we can identify that we need to condition the air of the room, right? So we need to know the properties of air first, right? So we need to know the properties of air, then only we can control the air, right? So in the starting few slides having these properties of air, then we can discuss how the air conditioner will work, right? So like our already we discussed the properties of air, steams, refrigerants, like air also should be studied. So right, so we can go with psychrometry and air processes to be studied in few slides. So we know what is atmospheric air. So the atmospheric air is not completely dry, but mixture of dry air and water vapor will be there, right? So normally the atmospheric air is a mixture of dry air and water vapor. So in atmospheric air, the condensed water vapor varies from 0 to 3% by mass, right? So in our normal atmosphere, there is a possibility of 0 to 3% of water vapor be present. Then the process of air conditioning and food refrigeration is often involving removing water from air and adding water to the air, that is humidifying and dehumidifying. So if you remove the water vapor from the air, means that is called dehumidifying. Then if you add water to the air, means that is humidifying. So we can, there is a two processes. We need to dehumidify or humidify whatever we want. Then the thermal parameters of moist air, where will be 7 criterions. So that the thermal property of moist air of first one will be dry bulb temperature, right? So you can note down the term dry bulb temperature. So the dry bulb temperature is the temperature of the air as measured by the ordinary thermometer, right? So actual atmospheric air temperature. Then the temperature of water vapor is the same as that of dry air in moist air. Then such a thermometer is called a dry bulb thermometer. Normally we will use the dry bulb temperature, dry bulb thermometer in stoichiometry because of its bulb is dry. So normally we will use a dry bulb thermometer to calculate the dry bulb temperature. Then we have the another property, wet bulb temperature. So that is denoted by TWB. So wet bulb temperature is thermodynamic adiabatic temperature in an adiabatic solution process and measured by a wet bulb thermometer. So we have a dry bulb thermometer and we have wet bulb thermometer. With the use of these two, we can measure the dry bulb temperature and wet bulb temperature of the atmospheric air. So the difference with these two is the bulb of this thermometer. So if that is dry bulb temperature thermometer, bulb should be dry, and if that is wet bulb temperature, the bulb should be wet. Then dew point temperature. So when the unsaturated moist air is cooled at a constant vapor pressure at a constant humidity ratio to a temperature, the moist air becomes saturated and the condensation of moisture starts. This temperature is called dew point temperature. So actually this is very important to my question. So dew point temperature, when the unsaturated moisture, you know what is the saturation line, saturation liquid line, and you know what is saturation vapor line, and you know what is unsaturated moist. Then you know what is saturated liquid, saturated vapor, and superheated vapor, right? So we know the difference of these two. So when the unsaturated moist air cooled at a constant vapor pressure or at a constant humidity ratio to a temperature, the moist air becomes saturated, right? So unsaturated moist air gets saturated, and the condensation of moisture starts during this process. So this temperature, the in between temperature is called as a dew point temperature of moisture. Then the next term is relative humidity. Relative humidity is defined that is RH. So you may know the term RH. RH means relative humidity. 5. The relative humidity is defined as a ratio of the mole fraction of the water vapor in the given moisture, mole fraction of the water vapor in the given moisture to the mole fraction of the water vapor in saturated moisture at same temperature and the same atmospheric pressure, right? So the ratio between the mole fraction of the water vapor in the given moisture, actual moisture, and saturated moisture. So normally relative humidity RH will be expressed in percentage. So the formula of phi will be Pw by Pw saturation. That is pressure of wet, that is water vapor divided by pressure of saturated water vapor, right? So then we have another term, degree of saturation, mu. So degree of saturation is defined as a ratio of a humidity ratio of moisture to the humidity ratio of saturated moisture, right? So humidity ratio of moisture and humidity ratio of saturated moisture at the same temperature and atmospheric pressure, right? So again, degree of saturation will be the ratio. So moisture with respect to the saturated moisture. Here we can take the humidity ratio, right? So humidity ratio of the both can be taken to calculate the degree of saturation. Then we have to know what is humidity ratio. So humidity ratio is the mass of water vapor interpressed in each kg of dry air. 1 kg of dry air. So how much amount of humidity is there? Like water vapor is there is called humidity ratio. Then it should be noted that the mass of water refers only the moisture in actual vapor state and not to any moisture in the liquid state, right? So actually the water vapor, this is water vapor, not water, right? So this should be in the form of vapor and not to any moisture in the liquid state like dew, frost, fogs or rains. So should be a vapor, right? So during calculation of humidity ratio, so we need to take only the parts, the mass of the vapor alone, right? Water vapor alone. Then the humidity ratio, like other several properties to be studied, enthalpy and specific volume is based on a kg, right? So we was the specific volume, then the enthalpy can be studied. That will be based on the per kg of mass, per kg of dry air, right? So we can have the specific volume. We know specific volume, that is small v is equal to capital V by m, right? So in the same manner, we can have the specific volume of moisture, that is specific volume is defined as the total volume of moisture divided by the 1 kg of dry air, right? So then we can have the specific enthalpy. Again, we know enthalpy, what you have, enthalpy by mass. The specific enthalpy of moisture is defined as the total enthalpy of the dry air and water vapor. So in our atmospheric air, we have dry air and water vapor, right? So the total enthalpy per kg of dry air is your specific enthalpy. Then the enthalpy values are always based on some datum plane. Usually the value of dry air is chosen as air at 0 degrees Celsius, and the zero value of the water vapor is the saturated liquid water at 0 degrees Celsius. So we have the zero value to get the specific properties. So actually this is your stoichiometric chart. So this can be accessed through your property tables and charts. Just if you open your property tables and chart, then there will be this trigonometric chart. So just you can able to find it in the table. So this trigonometric chart is used to get the properties of air, right? The properties of atmospheric air can be studied with the use of this trigonometric chart. Then in this trigonometric chart, we have a dry bulb temperature. We have like our 7 properties. So there will be dry bulb temperature, there will be wet bulb temperature, there will be relative humidity, there will be yes, then the total heat H. Then there is a pressure, right? So there will be some different properties. Then based on that, we can select our required state of the atmospheric air. So this trigonometric chart is important chart. You can take the properties of air with the given properties, right? So this is introduction about the stoichiometric chart. The stoichiometric chart graphically represents the thermodynamic properties of moisture. So it is very useful in presenting the air conditioning process. So we need this stoichiometric chart for air conditioning. So the psychrometric chart is bounded by 2 perpendicular axes and a curved lines. Just you can refer 2 perpendicular axes, 2 perpendicular x-axis, y-axis, and a curved line. x-axis, y-axis, and a curve line. So the horizontal ordinate axis represents the dry bulb temperature, in degree Celsius. Dry bulb temperature in degree Celsius, and vertical coordinates is your humidity ratio. Right. So humidity ratio is 0.1, 0.01, 0.02, 0.03 is the humidity ratio. Then the curved line shows that the saturated air is corresponding to the relative humidity 5 in percentage. So we can have the curved lines. So this 10% relative humidity, 20% relative humidity, 30%, 40, 50, 60, 70, 80, 90, and this line is 100%. Is 0% of relative humidity. Right. So the psychrometric chart is incorporates 7 parameters and properties. So they are dry bulb temperature, relative humidity, wet bulb temperature, dew point temperature will be there, specific volume will be there, humidity ratio, and the enthalpy will be there. Then the dry bulb temperature is shown along the bottom axis that we know. And the vertical lines extending upward from this axis is the constant temperature lines. Right. So these vertical lines will give you the dry bulb temperatures, right? Then relative humidity lines are shown on the chart as a curved line that we discussed. So the lines corresponding saturated air 100% is the upmost curved line on the chart. Then the 0% is horizontal alternate axis itself. Then the main air handling processes and the air variation in properties. So these are some properties. So there is a sensible cooling along with the cooling coil, sensible with the heating coil possible. So there is, from the name itself, we can identify sensible cooling along with the cooling coil. So if you provide a cooling coil, if the atmospheric air is passed through the cooling coil, we can get the sensible cooling. Then if the atmospheric air is passed through the heating coil, we can get the sensible heating. Right. So the sensible cooling happens when the air is cooled without altering the specific humidity. So the thing is, we need to keep the specific humidity constant. Right. So then only we can get the sensible cooling and sensible heating. Then during this process, the relative humidity of the air will increase. Just we can refer this 1A and 1A and 1B. This process is sensible cooling. Right. So if, during this process, sensible cooling, the relative humidity of air will increase. So where is relative humidity? Yes. So if you cool, so the relative humidity line, this is relative humidity line, right? So from this relative humidity will get increase if you cool. So say for example, if this is the 80% of relative humidity, means if you cool, we can get the 100% of relative humidity. Then the sensible cooling can only take place under the condition when the temperature of the cooling coil is not below the dew point temperature of the air being processed. So it should be this is dew point temperature, right? So it should be below the dew point, above the temperature of dew point temperature. Right. So also the sensible heating is similar to the sensible cooling, but with the dry bulb temperature increasing. So we need to increase the dry bulb temperature. So here is the dry bulb temperature, right? So yes, in the process here 2TA. So if we need to get the sensible heating, we need to maintain the dry bulb temperature. So we need to increase the dry bulb temperature of the air. It should be noted that there should be no water within the heating system, because the evaporation of water will increase the specific humidity of air. So again, this specific humidity should not increase while sensible heating. So we have to avoid the water in the that is water vapor in the atmospheric air to get the sensible heating. So these two possibilities there with the use of atmospheric air. Then there is adiabatic humidification and dehumidification using humidifier and chemical dehumidifier also possible there. So if you need humidification, you know what is humidification. We need to add more water vapor that by the humidifier. We need to add more water to humidification. So humidifier will add that humidifier is like our sprayer, right? So the humidifier will spray the water. So that from that spraying we can humidify the atmospheric air. Then if you want to dehumidification, we need a chemical dehumidifier that we have to remove moisture or water vapor inside the air. So we know we can have the chemical, just to be aware that some chemicals, right, to get dehumidifier. So in our if you in our electronics items packed, yes, you can identify that chemical dehumidifier. Right, so the adiabatic humidification occurs when the water vapor of which temperature is near the bed bulb temperature of the moisture is added to the air. Right, so the humidifier performs this function by supplying the water vapor. So during the adiabatic humidification process along the constant wet bulb temperature line, the specific humidity of air will increase. So specific humidity of air will increase. So I think yes, this is the process 2TA. 2A. So we need to adiabatic humidification that will happen. So during adiabatic humidification process along the constant wet bulb temperature line, constant wet bulb temperature. Where is wet bulb temperature line? Dry bulb. This one will be wet bulb temperature, right? So this process, right? So constant wet bulb temperature line. So if you refer that psychrometric chart, so wet bulb temperature line will be like this. So we should maintain the constant wet bulb temperature during this adiabatic humidification. Also, we need to increase the specific humidity. So we need to increase the relative humidity of the system. Then reduction in dry bulb temperature will happen as the evaporated water will absorb it, right? Also reduction in dry bulb temperature, right? So reduction in dry bulb temperature also possible, reverse manner happens as evaporated water will absorb heat, that is dehumidification. So there is possibility of humidification and dehumidification. Also there is a possibility of sensible heating and cooling. So with this introduction, we are entering into the chapter air conditioning. So the purpose of air conditioning is to maintain the atmosphere of an enclosed space at a required temperature, humidity and purity. So when maintaining the atmospheric air with the required temperature, with the required humidity and with the required purity also. Then the refrigeration system is at the heart of AC system. So also we will actually this AC system is application of our refrigeration system. Then there is 3 different types of AC systems available. One is a self-contained AC system, then a refrigerant circulating AC system, then we have chill water circulating AC system. So these are some types of AC system. Then we can know what is air conditioning. The air conditioning is the science which deals with the supply and maintaining desirable atmospheric condition irrespective of external condition. So the external condition may change during the year, but we need to maintain our desirable internal atmospheric condition. So the air conditioning may be defined as a simultaneous control of temperature, humidity, motion of air, and the purity of air within the enclosed space. So we need all these four requirements. So we need to control temperature, we need to control humidity, we need to control motion of air, and we need to have a pure air. Purity, we need to control the purity of the air within the enclosed space. Then we have the classification of air conditioning as stated here. So according to the purpose of air conditioning, we have comfort air conditioning system, then we have industrial air conditioning system. Then according to the session of a year, so we have a winter air conditioning system, and we have summer air conditioning system, and year-round air conditioning system, all weather conditioning system. Then according to the equipment arrangement, we can classify that by central air conditioning and unitary air conditioning. Also by according to the working substances used in the AC system, we can classify that by all air system, then chilled water system, then air water system. So these are some factors affecting the comfort air conditioning. So the temperature of air. So the temperature of air should maintain maintenance of any desired temperature within closed space, irrespective of the outside temperature. So this is done by the addition or removal of heat. So we can control the temperature of air. Then also we can control humidity. Maintaining the relative humidity means to maintain moisture of the air by removing and adding the moisture by proper means. So we can humidify and dehumidify. Then human body is comfortable, at 21 degrees Celsius, and the RH value should be 60%. That is relative humidity. So this is our comfortableness. So we should maintain the atmospheric air with this condition. So we should maintain 21 degrees Celsius and 60% of RH. So to maintain this temperature, we need sensible heating and cooling. So also to maintain this RH, we need humidification and dehumidification process. Then we need purity. So we do not feel comfortable while breathing contaminated air, even if it is at a comfortable temperature and RH. So proper filtration and the cleaning of air is required. So then only they provided the filters inside the AC. Then the mention of air circulation, also the motion of air. Right. So the motion of air inside the room also needed. So the circulation of air is important to maintain the constant temperature. So we can control the temperature with the use of the circulation of air. So there must be equal distribution of air throughout the space to be conditioned, right? So there will be some circulation of air. Then only we can control the temperature of the air inside the components. Then we can look at the components of air conditions. So we can have circulation fan, we can have air conditioning unit, we can have supply duct, we can have supply outlet, then we can have a return outlet. So actually this is for large areas. So supply outlet will be there, then return outlet will be there. So if you seen in our big buildings like our malls, then any corporate office, so the supply outlet and return outlet will be there. So there will be a filters also. So the circulation fan moves the air to and from the room. Then the air conditioning unit, so it is the unit which consists of cooling and dehumidifying processes for summer and heating and humidification in winter. Just note the terms: cooling and dehumidifying for summer. Then we need to heat and humidify for winter. Right. Then supply duct, so it directs the conditioned air from the circulating fan to the space to be air conditioned at a proper point. Supply duct, so there is a duct, so wherever you want we can take. So just you can imagine a big mall, a hyper malls, right? So there we, so wherever we want we can take this supply duct to give the outlets. Then the supply outlet, these are the grills which distribute the conditioned air evenly in the room. So also we need returned outlets. So these are the opening in the room surface which allows the room air to enter and return the duct. Then we need filter. The main function of the filter is to remove dust, dirt and other harmful bacteria in the atmospheric air. So actually these components of air is for commercial buildings, right? So we need a supply duct, we need a supply outlet, we need a return outlet, also we need filters. So the so in our commercial applications we have this air conditioning unit in a compact manner. But in the case of buildings, we need these components. Right, then we can enter the types of air conditioning. So we have summer air conditioning. So it is used where cooling and dehumidification of air is required. So hot, that as I said earlier, we need cooling and dehumidification of air for summer. Hot flows through the damper and mixes up with the recirculated air. Right, so in the atmospheric air will be get hot, right? So we need cooling and dehumidify that. Then the mixed air passes through the filter. Then the air passes through the cooling coils whose surface temperature is below the dew point temperature of the air. So we need to cool. Then the air gets cooled and dehumidified. Condensed water gets collected in the summer. Then after that it passes through the heating coil to get heated to desired temperature. Then the conditioned air is applied to the room by fans. So we need both cooling and dehumidification of atmospheric air during summer. So actually this is the flow diagram of our summer air conditioning unit. Just you can refer this. So this one. So outdoor air mixture is taken. Then this is passed through the outdoor air damper. So then so we can have the circulator air in the mixing chamber. So the outdoor air intake and the circulator return air from the room is mixed with this use of mixing chamber. Then this air is passed through the filter. Then we have the heating, the humidification, right? So then to get dehumidification, right? So then we need to provide cooling coils. Then we can get the air cooled. Then again this is passed through the humidifier. So we need humidification and dehumidification in the flow. Then we can get the chilled dehumidified air. Then this is passed through the supply air diffusers, right? So actually this is the inlet duct. Then this is the outlet duct. Inlet duct, then outlet duct. So wherever we want we can Actually, this is a duct. So this line, this passage is called as a duct. Then yes, these are the components involved in the summer air conditioning units. So then maybe we can exhaust the air if we want. Also, we can use the circulated air circulation. Then also we can take the air outside air intake. Right. So in few areas in the world, it is very difficult to live in winter, right? So winter also need to condition air. So the winter air conditions are used to heat the space for human comfort. This is second type, right? So it is its input and output is reversed to that of summer air conditioner. So we know. So in summer air conditioner, we need to cool the air and we need to dehumidify. So here the opposite. So we need to heat the air and we need to humidify that. So the outside cold air is taken in and hot humidified air is supplied to the room in winter air conditioning. So in winter outside air's temperature is less than the human comfort temperature and RH is also less. So its components are same as that of a summer air conditioning system. Only the difference is heating coils. So where in the case of summer, we will use the cooling coils. So heating coils are used whose temperature is greater than the dew point temperature of incoming air. So air gets heated and humidified to a designed condition and supplied to the room. Then actually this is the flow diagram of our winter air conditioning system. So the other components are same, but here we have the heating coil, right? Preheater and reheater. Then we have a humidifier and dehumidifier. Then we need three coolers also. So we need fan to circulate the air. So this conditioned air is passed through the room wherever we want. Then the exhaust air, the outlet is to again get circulated in the air conditioning. So these dampers used to regulate the airflow. So there is some dampers. So these are some dampers. So to regulate the airflow, we need dampers. All other components and applications are same except the heating coils. Then we can have the year-round air conditioning system. So in several countries, both winter, summer is uncomfortable. Right, you know very well. So under such adverse weather, adverse weather condition, air conditioners must provide comfort conditioning throughout the year, right? So such system is known as year-round air conditioning. So actually in summer we need to give the conditioned air with cooling and dehumidification, and in winter we need to give heating and humidification. So we need to control both humidification and cooling, heating and cooling, humidification, dehumidification through the year. Right. So the working of year-round air conditioning units. So year-round air conditioning can be obtained by using vapor as a refrigerant with additional humidifier and reheater. So we can use vapor as a refrigerant with additional humidifier and reheater. So we need this humidifier and reheater to get the application of this year-round air conditioning. Then we need air washer. Actually, this is for humidifier. So humidifier is maybe air washer. So in air washer, an air is passed through the water stream. The temperature of water is below dew point temperature of incoming air. For cooling purpose, we can use this air washer for both cooling and heating. So if the temperature of water is below dew point temperature of incoming air, we can use that for cooling. Then if the temperature of the water is above dew point temperature of the incoming air, we can use that for heating. Then according to the outside air condition and the room designed condition, temperature of water is maintained either by external cooling or heating. So we need both heating and cooling. So because of that, we can use the air washer as an air or reheater. Actually, this is the line diagram of air washer. So actually, air in, air get will in, then there will be a spray of water. Then this will collected in the bottom of the exam. Then again, if you pump, we can circulate this air, circulate the water. Then actually, this natural heat transferring will occur here. Then we need these eliminator plates to control the supply and out of the air, right? So this is actually air washer. So by using vapor as a refrigerants, so these are some possibility. So in this system, cooling and heating coils act as a evaporator and a condenser. So we know what is evaporator and what is condenser and what are the functions of these two. Then so in year-round applications, we have this evaporator and we have the function of evaporator and condenser with the use of these heating and cooling coils. Then vapor is used as refrigerant here. So the compressor is required for the circulation of refrigerant. Then the valves are used to control the flow rate and the directions of the refrigerant according to the requirements. Then pumps also used to regulate the flow of water. So actually this is your year-round air conditioning water in winter circuit. So actually again the same, right? So just we can have the condenser here. Condenser, then air washer, humidifier. The other components will be same. Then so year-round air conditioning for winter, the cold air is taken mixed with the recirculated air. Then it is passed over the heating coils, which acts as a condenser and gets heated. Okay, so in winter, actually this is passed through the heating coils. That is a function of condenser and gets heated. Then it is then humidified by passing it through humidifier. So actually in winter, so the air gets passed through the heating coil for the condensation purpose. Then again it's allowed to humidification. Then this conditioned air is supplied to room where hot and humidified air is required. So during winter, we need this, right? So we need heating of air and we need humidification. So refrigerant is then passed through to the evaporator, where it's evaporate using outside air. So again, so after the process over, we will pass it through. We will pass this refrigerant through evaporator. Then so there will be evaporation process. Then receiver and compressor are required for the proper circulation of the refrigerant again. So we know how the refrigerant will work. So actually this refrigeration system also the heart of our AC. Then there is year-round air conditioner for summer. So the hot outside air is taken in and it is passed through the filter that we know. Air is mixed with the recirculated air. Then it is now passed through the cooling coils, which act as an evaporator. So if heating coils, we need a condenser. If cooling coil, we need an evaporator, right? So cooled and dehumidified air is supplied to the room, right? So then, so in summer, we need a cooled and dehumidified air. Then the refrigerant is passed through the condenser, where it condenses and returns the receiver. So after the actually in winter, first the air is passed through the condenser, then operator. In summer, first it is passed through the evaporator, then condenser. Then the condensation is done by the outside air only. So this is actually the year-round air conditioning setting for summer. So actually in summer we need this evaporator and this after heater, it is heater. So here we have condenser, we have evaporator. So there is a change, there is a shift. So there will be evaporator and condenser in year-round air conditioning system. So an evaporator during the winter operations acts as a condenser in summer and vice versa. So we can use evaporator as a condenser, also condenser as an evaporator. So we can vice versa. In both the systems, condensation and evaporation of refrigerant is done using the outside air. So no external cooling or heating is required. So the proper valve adjustment is alone enough. Is required and is control is required for proper functioning of the system. So we no need any external cooling or heating in the year-round air conditioning system. Just a proper valve adjustment is enough. Also we need a control. We need a control for proper functioning of the system. So with this we can conclude the unit 4. So we have the refrigeration and the air conditioning. So just there is some few problems alone. Just we have some formulas. So with that formula we can try to solve the problems. Then just try to recall the properties of the all pure substances. So we need to use the property tables and charts. Also we need to use the psychometric charts also. So we can take the properties of the given state from the property tables and charts. Then in the next class we can go with the unit number 5. There is heat and mass transfer. So that also there is a lot of thermodynamics involved there. Just I think you were writing your assignments. So the deadline is before the next Wednesday, right? So there is 50 points for your assignment. Just try to finish your assignment before the given due time. Right, so we can take the unit 5 in the next class. Then if you have any queries or doubts in the unit 4, just you can ask, or else you can hang up. Thank you. Have a good day.
Thank you.
Thank you, sir.
Thank you, sir.